Hi, welcome back to another session. Actually, this is the last session of week 3. I want to continue the problem that we were talking about in the previous session. And one more time, and for the last time, you have to pay attention because you've got to be able to work out all of these problems. They're not very difficult, but if you haven't seen them before, you might not be as familiar with the procedure. So make sure that you can work these things out. So what are we talking about right now? We're talking about the problem that is encountered in the real world when we have a limited supply of any asset that needs to be allocated over 2 periods of time. The 2 periods, by the way, they don't have to be 2 years, but I mean, it's easier to think of them as 2 years. Each period could be 10 years, each period could be even a century. It could be a period of time, I mean, you define it. But the important thing is that we have an asset, we've got to divide it over these 2 periods. What is the most optimum way of allocating that particular asset? According to the theories of neoclassical economics, which really makes sense, and nobody is going to dispute that, is that we will arrive at that particular allocation that is efficient. And that efficient allocation is going to be the allocation that maximizes the present value of the net benefit, which is another way really of talking about the consumer surplus that we spoke about last time, that is really central to most of the ideas of economics. As we have found in the previous session, once we do that and we apply an interest rate in order to discount the future into the present, we will inevitably find out, which is obviously true, that the discount rate always favors the present. And that is precisely why environmentalists do not like to use an interest rate. Actually, the best solution from a purely environmental perspective is not to use any interest rate. But since it's very difficult not to use any interest rate, some environmentalists right now have agreed to use a very low interest rate, which is neither here nor there given the current interest rate environment, but that's really an exception. We've never had zero interest rates and negative interest rates before. And one would hope that these things are not going to last for very much longer, although for all practical purposes they've lasted for the past 5 or 6 years, ever since the Great Recession. What is important for us right now is to continue that particular discussion. Now, in order to do that, I have to remind you of a few of the basics so that we will be able to retouch what we were talking about earlier. Our basic assumption is the demand curve. So we have a demand curve that is P is equal to 10 minus 0.2 Q, which is the same thing as saying that Q is equal to 50 minus 5P. Usually economists define a demand curve in terms of Q. So Q is equal to 50 minus 5P, which is really the same thing as P is equal to 10 minus 0.2 Q. We're going to assume that we're talking about 2 periods. And we're going to assume in this particular case that our supply is limited to 40. Why am I limited to 40? Again, as a quick reminder, because if I'm not going to limit it and I apply this given that my marginal cost is 4, then in each period I'm going to use 30. So if I'm going to use 30 during the first period, 30 during the second period, because I'm assuming the same demand curve is going to hold in both periods, then I need only 60. So if my quantity is 70, I don't have to worry about allocation if I'm concerned only with 2 periods. So in order for me to have a problem of allocation, I've got to assume that the supply is less than what I would have consumed in the two periods. Now I am assuming, again, if you still recall, that my marginal cost is 4, therefore that is the price. So when I plug this into here, I will get a quantity of 30. 4 times 5 is 20, 50 minus 20 is 30. By the way, the problem or the diagrams could become even simpler if we assume that the marginal cost is 0. When the marginal cost is 0, what happens over here? The quantity becomes 50. And not only that, when it comes to the issue of constructing that model whereby you have the demand curve of the first period superimposed on the discounted demand curve of the second period, that model again becomes, at least the numerals become different, because then 10 minus 0 right now instead of 10 minus 4. When marginal cost is 0, then there's no need to subtract anything. And we're assuming that the interest rate is 10. Once we solved the problem, if you still recall, we wound up with this, that price during the first period is 5.905, and during the second period 6.096. Now that is extremely important because it's going to show something that we didn't get a chance to stress earlier. Now the difference, and we're going to say it only once, and we're going to come back to it more than once in the future, at least we're going to apply it, and we don't always have to explain it. We're going to say that the difference between the price in the market and the marginal cost is called marginal user cost or rent. So during period 1, rent is 1.905 because it's 5.905 minus 4. During period 2, it's 6.096 minus 4. So during period 1, it's 1.905. During period 2, it's 2.096. Now, look at these. What do you notice? I hope that all of you, or most of you, have noticed immediately that this is this plus 10%, or this is this discounted by 10%. So the discount rate determines what happens to rent. Rent increases by the discount rate. Had we used a discount rate of 20%, then the marginal user cost during the second period would have increased by 1.905 times 1.2, which would have been, closer to 2.2 over here. Plus 4, then this would have been probably 6.2. So it will change everything. It will change the quantity allocated, and it will change the price because it has changed the rent portion of the price, but it does not change the cost of production. The cost of production is still going to be a marginal cost of whatever you assume to be, either 4 or 3 or 6 or 0 or whatever the case might be. Now, given all of these things, how are we going to determine, and that's the question that we were dealing with last time, whether this particular allocation is sustainable? Well, if you still recall, before we go through this, let me remind you one more time. We said that in order for it to be sustainable, then the first period must not grow at the expense of the second period. That's to say, the total benefit of period 1 must not be greater than the total benefit of period 2. If it is greater than the total benefit of period 2, it means that the current period, the present, is growing at the expense of the future. Now that violates this principle of sustainability. So we know, according to what we have been talking about earlier, that this allocation of 20.476 in one and 19.524 in the second period is efficient. Now we've got to determine on whether this is in accordance with the principle of sustainability. So we have to calculate right now what is the benefit during period 1, and obviously what's the benefit in period 2. And what I want you to do is to be able to follow this meticulously, because you've got to be able to reproduce it, and we're not going to talk about it again. So what happens in this case? Well, remember we have that demand curve whereby this price axis over here, the intersection is 10, and this is 50, right? We have a marginal cost of 4, and then we said that during period 1 we're going to be using 20.476. When the quantity is 20.476, the price is going to be 5.905. So how much is the benefit? I hope that you all recall, because we've spoken about it twice, and I'm sure all of you have seen it before. We're really talking right now about the area that is under the demand curve, but that is above the marginal cost. That is the surplus, the benefit in this case. So we've got to calculate the area of all of this triangle plus this rectangle. Now, what is the area over here? It is this, which is 20.476 times this. What is this? It's the difference between these two. So it is 20.476 times 1.905. So that is the area of this rectangular block. Now, obviously, these are not drawn to scale. So what is the area of this triangle? The area of this triangle, obviously, is the base times the height over 2. The base, again, is 20.476 times the height, which is 10 minus this, 4.095 over 2. If you do these calculations, and assuming I didn't do a mistake, this would be 80.93139. So the area, therefore, of the benefits, net benefits under period 1, is going to be the 80.93139. We have to do the same thing for period 2. Now notice again, it's very simple. The demand curve, 10, 50. Marginal cost is 4. The quantity is 19.524, which gives you a price of 6.096. Therefore, we've got to find out the area of this plus the area of this, which is going to be the 19.524 times this, which is 2.096, plus the base times the height over 2, which is 19.524 times 3.904 over 2, which works out to be 79.033152. So immediately, what do you know? Immediately what you can say is that we have violated the principle of sustainability, because the present has grown at the expense of the future. So, what is the conclusion? And this is what I've mentioned a couple of times already. The conclusion is that if we depend on the market to get an efficient allocation, then that efficient allocation will be in violation of the principle of sustainability. Now, the question then becomes, can we do something to restore sustainability? And I'm going to tell you that yes, we can. We're going to go ahead and restore sustainability. Now, how am I going to restore sustainability in this particular case? Well, I'm going to restore sustainability, as you can see, by having government interference one more time. That's to say, the market cannot do it by itself. So what am I going to do? I'm going to do what very many countries, by the way, in the Gulf, in the Arabian Gulf, are doing, what Alaska does, what Norway does, what very many countries are doing. You go ahead and you do an efficient allocation. But you put aside, you save part of the revenue from that particular allocation and you pass it along to the future. So in this case, to show you how it will work, I'm going to take away the 0.93139 away from the first period. I produce the efficient allocation, I save the 0.93139. I pass them along to the second period. How do I pass them along? Well, remember the interest rate is 10%. So by the time it is the second period, they would have grown to 1.024529. But the second period was 79. So if I add to the 79 the 1.02, what do I get? I get an 80.057. So right now, period 2 is going to have 80.057, while period 1 is going to have 80. So period 2 is going to have slightly more than period 1. Therefore, I have restored sustainability. I am no longer growing the present at the expense of the future. But notice how it was done. It was done through government interference. We had to go ahead and interfere with the market to set up that particular fund that will save the money and that will pass it along to the future. So the market by itself cannot lead to sustainability without interference. As simple as it looks, though, right now, I've got to mention a couple of other things that are not in the book, and again, we're responsible for them. So I'm going to go over them very, very quickly. But I wrote a few words over here so that you'll be able to look them up. What is the procedure for me to find out whether the net benefit of the second period is smaller than the net benefit of the first period? Is it simple for me to go ahead and do these calculations? And how difficult is it going to be if I have 10,000 different oil wells and so many different coal mines and so on and so on and so on? It could be really a task that can never ever be done. So there is really an easier way of answering the same question. We don't need to go ahead and do all of these calculations, because there's a gentleman by Hartwick. It's called the Hartwick Rule, and it was introduced only around 40 years ago. To be precise, I think 1977, exactly 40 years ago. So the Hartwick Rule says we can be assured of sustainability provided that the capital stock in that particular country, society, or obviously what we're interested in is the world, in the globe, is going to be constant. If the capital stock is constant, then we will be able to produce the same amount of consumer goods so that they'll be consumed, and therefore sustainability will be maintained in the future, will be as much as that of the present. But how can I do that? How can I make sure that the capital stock is constant? He's saying that can be assured through investment, through manufactured capital. If I take all the rent, all the MUCs, and I invest them, then the capital stock, the manufactured capital, will increase, and that would assure me that the future is going to be at least as large as the present, and so sustainability is going to be assured. What is it that's wrong with that? Well, environmentalists, at least some environmentalists, objected to this. Because what is capital? capital, contrary to those that haven't studied environmentalism, you think of capital only as being the manufactured goods. In economics, you always say land and machines. But environmentalists say that we have manufactured capital and we have natural capital. So what do we mean, therefore, when we say that the sum of capital is going to be the same? The sum of capital can be the same only if you believe that one can substitute manufactured capital for natural capital. Because our economic activities, when we say right now that that the scale is so high, it is greater than the absorptive capacity, if you still recall, once you go back to that circular flow diagram. What we are saying is that we are depleting, we are eating into the capital that is natural, into our natural capital. Now, as we eat into natural capital, can we use manufactured capital to substitute for it? Hartwig and mainstream economists believe that yes, the principle of sustainability, the principle of substitutability applies in this case. That's to say, we don't have to worry about sustainability because manufactured capital can substitute for natural capital. If you believe, and I want to leave it here, I don't want to discuss it at length because we can really get caught in this and spend hours on it. If you believe that manufactured capital is capable of acting as a substitute for natural capital, then you believe in what is known as weak sustainability. So weak sustainability is simply a description of sustainability when total capital is constant, but since natural capital is being depleted, it implies that manufactured capital is substituting for natural capital. Many environmentalists, not all, many environmentalists, and in particular Mr. Daly and all the people who have been influenced by him, they speak about strong sustainability. And in strong sustainability, they argue that manufactured capital is not capable of substituting for natural capital. You might have as many machines as you want, and you could have trillions of dollars in capitalization. But if it so happens that there is no longer any fertile soil, for example, how can these machines and how can this financial capital substitute for the fertility of the soil? It cannot. Or for clean air, it cannot. Or to affect the water table, it cannot. Or to restore the equilibrium to, let's assume, the oceans. It cannot. So strong capital says that the single most important thing is the integrity of the natural capital. So natural capital must be maintained. We must not ever operate at any level whereby the natural capital is going to be depleted. And if you still recall from the ISEW, what Daly and others are saying is that we are already operating at that particular point, whereby we are eating into our natural capital, and therefore sustainability is next to impossible. And that's why eventually we speak about steady state economics, whereby you've got to decrease the rate of economic activity and the rate of growth. So instead of substitutability, their argument over here is that there is a complementarity between the capitals. You need them both at the same time, and sometimes in a particular ratio. You cannot just go ahead and substitute one for the other. And this, by the way, is the last thing that we're going to talk about in this. So I will talk to you next time about a new chapter. This should be all that we are going to present via the videos on chapter 3. No, sorry, not chapter 3, on week 3.